How long does your test suite take to run? If the answer is more than 5 minutes, I want you to think about what happens in practice. Developers stop running it locally. They push to CI and wait. CI takes 10 minutes. They have already moved on to the next task. They get a failure notification, context switch back, figure out what broke, fix it. That cycle costs more time than the test run itself. And it happens because nobody optimized the suite for speed. The default in pytest is sequential execution. One test at a time. If you have 500 tests and each takes 2 seconds, that is 16 minutes. It does not have to be that way. Modern computers have multiple CPU cores. Most of them are idle during a test run. Pytest-xdist lets you use them. It distributes your tests across workers, each running on a separate core, in parallel. That 16-minute suite might run in 3 minutes with 4 workers. The same tests. The same assertions. Just executed simultaneously. This episode is about how to set that up, how to make sure your tests are safe to parallelize, and the specific mistakes that will cause random failures if you do not address them first. Because parallel testing is not just a config option you flip. It requires your tests to be truly independent of each other. And that constraint, while it sounds like a burden, actually makes your suite better. Let us get into it. Pytest-xdist works by spawning multiple worker processes. Each worker is a separate Python process with its own memory space. The main pytest process distributes tests across the workers, collects results, and aggregates the output. Because workers are separate processes, they do not share state. That is by design. A variable set in one test cannot affect a test in another worker. Installation is just pip install pytest-xdist. Then you run pytest with the -n flag followed by a number. Pytest-n4 runs with 4 workers. Pytest-n auto lets xdist detect how many CPU cores you have and use them all. Auto is a good starting point. If you have 8 cores, it spawns 8 workers. Each worker picks up tests from a queue and runs them. By default, xdist uses a load distribution strategy. Workers grab the next available test as soon as they finish the current one. This works well when tests have variable run times, because fast workers do not sit idle. There is also a dist byfile option, which groups all tests in a file together on one worker. This is useful if you have setup costs per file that you want to avoid duplicating. And dist byscope groups tests by their fixture scope, which can reduce redundant fixture setup and teardown. The right distribution strategy depends on your suite. Start with the default, measure, then tune. Here is the hard part. Not all test suites are ready for parallel execution. The number one cause of parallel test failures is shared state. If 2 tests write to the same database table at the same time, they can interfere. If 2 tests create a file with the same name, one overwrites the other. If 2 tests modify a global variable, all bets are off. For tests to run in parallel safely, they must be truly independent. Each test should set up everything it needs, run, and clean up. It should not assume anything about what other tests have done or will do. Here is how you identify the problem areas before they bite you. Run your suite sequentially first. All green. Run with -n2. If you get failures, you have shared state somewhere. Look for tests that rely on database rows left by a previous test. Look for tests that use hard-coded IDs that could collide. Look for tests that modify module-level variables or singletons. Look for file-based operations that use fixed paths. The fix is almost always the same, make each test self-contained. Use fixtures with function scope to create and delete data. Use unique identifiers, like UUIDs, for anything that touches shared storage. Use temporary directories instead of fixed paths. When you fix these things, your suite becomes more reliable in sequence too. Parallelism does not create the problem. It exposes it. Let us look at code. Here is a concrete example of a test that breaks under parallelism. And how to fix it. The broken version, a test function called test-user-creation. It creates a user in the database with email test@example.com. Another test, test-user-login, looks up the user with that same email and logs in. In sequential mode, test creation runs first, test login finds the user. Both pass. In parallel mode, test login might run before test creation. It finds nothing. Fails. Or both tests run at the same time and one of them gets a unique constraint violation. Because both try to insert the same email. The fix has two parts. First, each test creates its own data. Test user login creates the user it needs, then logs in. It does not depend on test creation having run. Second, use unique data. Instead of a hard-coded email, use a fixture that generates a unique email with a UUID. Test at uuid.example.com. No two tests will ever collide. Now with pytest-xdist, both tests can run simultaneously. Each creates its own user with a unique email. Each tests what it claims to test. Neither knows the other exists. Here is a bonus pattern. Use a database transaction fixture at function scope. Before each test, open a transaction. After the test, roll it back. The test writes to the database, reads back, asserts, and cleanup is automatic. Nothing persists between tests. Works perfectly under parallelism. There are a few more things to know before you run with xdist in production. First, logging and output. With multiple workers printing at the same time, the default pytest output becomes unreadable. Install pytest-sugar or configure your output format to handle parallel runs cleanly. xdist also has a -v flag for verbose output that groups results by worker. Second, fixtures with session scope need special attention. By default, a session-scoped fixture runs once per worker, not once per session. If you truly need a fixture to run once across the entire parallel run, use the scope equals session with xdist group parameter from the pytest-xdist documentation. This requires a little extra configuration but is worth it for expensive setup like spinning up a server. Third, test ordering. xdist does not guarantee test order. If your test suite has any hidden ordering dependencies, where test B only passes because test A ran first, parallel execution will find them. Treat it as a linting pass for ordering bugs. Fourth, your CI environment might limit parallelism. A container with 2 vCPUs cannot effectively run 8 workers. Set -n to match your CI resources. Auto on a 2-core container will spawn 2 workers, which is correct behavior. Fifth, measure before and after. Use pytest with the --durations flag to find your slowest tests. Those are the ones that benefit most from parallelism. Let us bring it together. Pytest-xdist is one of the highest leverage improvements you can make to an automation project. Installation is one command. Configuration is one flag. But the benefit compounds. A suite that runs in 3 minutes instead of 15 gets run more often. More runs means faster feedback. Faster feedback means smaller, safer changes. The prerequisite is test independence. Each test must stand alone. No shared state. No hard-coded IDs. No ordering dependencies. If your suite has those problems, xdist will surface them. Fix them, and your suite becomes more reliable in all modes, not just parallel. Start with pytest-n auto on your next run. If everything passes, you are done. If failures appear, treat them as bugs to fix, not parallel problems. They were always bugs. Parallelism just made them visible. Coming up next, test data management. How to handle the data your tests need without hard-coding values, without polluting your database, and without slowing down your suite. We will cover factory patterns, fixture-based data generation, and how to use external files like JSON and CSV to drive hundreds of test cases from a single function. Subscribe so you do not miss it. See you in the next episode.